Okay, well, we've got our diamonds now, right? We go to Russia, South Africa, other parts of Africa as well, Canada. We've talked about how diamonds occur in these kimberlite pipes. We recover them. Um, Somebody fills a bucket up with diamonds. And then the next question is, well, what happens, right? So then there's the diamond market. And the diamond market itself is really interesting. I alluded to this in the previous video. The majority of diamonds, at least those that are in the kind of gem quality realm, right? Remember, that's about 20%. Those actually all get to take a field trip to Belgium. Well, not all of them, but the majority of them. And in the 15th century, Antwerp, Belgium was set up as essentially kind of the world's diamond exchange, and to a large degree it still is. So of the raw diamonds, right, so not yet cut and polished and faceted, about 85% of the raw diamonds go from the mines to Antwerp, and at that point they're kind of sold and distributed to different diamond dealers that head off to different countries. There's kind of these sub-diamond exchanges globally. Interestingly enough, about 50% of those actually end up returning to Antwerp to get cut, polished, faceted, shaped, kind of processed so that they can be used for jewelry. And in the diamond district in that town, there's about 400 workshops, about 30,000 people employed. So it's a huge industry, right? It's again kind of the global capital of diamonds, the diamond district of the world. So in any given year, kind of think about the volume of diamonds and kind of the finances. There's about $16 billion worth of cut stones that pass through Antwerp in any given year. That is a pretty crazy number. And so, what really is all of the work there? So I mentioned the workshops largely are cutting and polishing diamonds. This is a technology that really kind of arose once we understood the structure of diamonds, so we can cut them kind of along, certain planes in their crystal lattice to kind of help them reflect light more vibrantly, right? And 200 years ago, we didn't necessarily fully understand the chemical structure of a diamond, and so cutters would make an attempt, and actually, oftentimes, they would even put foil under the diamonds to reflect the light back. But now we really understand kind of how to cut them with respect to their crystal lattice to make them shine. So shiny diamonds, right? We're at the point where we've got cut and polished diamonds. The next thing that really happens is the diamonds then get graded. And primarily, aside from size, remember diamonds are rated by carat. Carat is about as much as a pea, right? It's a unit of weight. But aside from that, so the colors of diamonds really kind of come from two different things. Depending on the pressure, there could be kind of defects in the crystal lattice, like structural defects from deformation from too much pressure or kind of differential pressure. And then additionally, you can have chemical impurities kind of at the parts per million level that reflect light differently. And actually, this is nothing new, right? We see this with quartz, right? Quartz, pure silica dioxide quartz is just crystal clear, transparent. But you've got rose quartz and kind of milky quartz and smoky quartz, and all those things have to do with parts per million impurities. Diamonds work the same way. Although, in some cases in diamonds, we really want the color impurity. We'll talk about that in a second. In other cases, we don't want it. So there's really kind of one most reviled impurity in diamonds, and that reviled impurity is nitrogen. It actually makes diamonds kind of tend to yellow. And so you can see here, so yellow, nobody wants a yellow diamond. Well, some people do. And the opposite end of that spectrum is like an absolutely perfectly clear diamond. But it's not that straightforward. There's actually a gradation, and you can see here. This is the internationally kind of used color grading scale for diamonds. And again, this is some of the work that they're doing in Antwerp, right? Of technically looking at these, deciding what the clarity rating of that diamond is, and obviously then there's a price associated with that. So this is a diagram showing some raw uncut diamonds, the types that would show up in Belgium, and you can see again they're rating from clear on one side all the way to diamonds that don't look that great in the rough, but those would very likely kind of polish up and appear yellow. And so actually bumping down and looking at the international color grading scale, you can see that's the scale we use, perfectly clear to yellow. And the diamond workers kind of decide for each individual diamond where it falls along that spectrum. So, when you're kind of considering an individual diamond, you have its clarity rating, you have its carat, which is its size, and then additionally, there's lots of different cuts and things. I'm not necessarily going to get into the different types of diamond cuts. But I mentioned nitrogen. No one's into yellow diamonds. Well, again, I think people are. If you think back to that picture I showed you earlier of the saw blade, those were yellow diamonds in there, right? So those were not necessarily ones that had kind of a high demand. So outside of yellow, there's quite a few different kind of naturally occurring colored diamonds, and those are actually what we consider fancy diamonds, right? They've, capital F, fancy. And they come in a couple of different colors, but really from some standard processes that happen, kind of, again, in nature. So you can get naturally occurring brown diamonds. Sometimes you'll hear them referred to as chocolate diamonds. That actually has to do with a deformation in the crystal lattice, which changes the way that the light moves through the diamond. It's not necessarily a chemical impurity. So continuing along, fancy diamonds, naturally there are green diamonds. That has to do with diamonds that were subject to naturally occurring radiation. Obviously, one of the things that we're going to kind of go to next is we can change the colors of diamonds. Green is a good example. Purple or violet diamonds are weird because it's a little bit of both. It actually has to do with the deformed crystal lattice as well as the presence of hydrogen in the crystal lattice. So again, one of the most popular kind of diamonds in the world to go and visit, it's at the Smithsonian, is the Hope diamond, which is colored blue because of parts per million impurities of the chemical boron. So really, these are the kind of naturally occurring fancy diamonds, right? Remember, no one likes nitrogen, although diamonds that are included with nitrogen tend to be cheaper, right? So again, even cheaper, kind of approaching the type of diamonds you'd use industrially. So the last thing I wanted to talk about is actually this diagram, which really kind of puts together a couple of the things that we were just talking about. You can see there's lots of different colors of diamonds, and these are the ways that we artificially color them. So you can see, obviously we talked about green. Those, diamonds that are green tend to have been exposed to radiation. So we can take diamonds and expose them to radiation, and they turn green. We can apply a surface coating to the diamonds. Not the coolest way to do it, but we can definitely change the color with a durable surface coating, high pressure annealing. So lots of kind of chemical lab sorts of treatments. We can modify the pressures, we can modify the temperatures, we can expose them to radiation. We can actually make lots of different colors of diamond. But to kind of to bring that back, again, kind of thinking about people who are purists, really this kind of short list, these are the types of colors that can occur naturally. All right, well, that's actually going to finish up our discussion on diamonds. We've got a few more gemstones to get through, and then we'll finish up the module.